Okay, thank you everyone. Thanks for coming to the conference and also attending my talk. Yep, this is the first presentation of the day. It's going to be in English also. And I'm going to be talking about geospatial data and how we use geospatial data in our organization. So a brief intro about me. I work in the World Food Program. It's an organization, it's a UN agency that is currently focusing on delivering food for people in need globally. So usually when there is an emergency going on somewhere, or there was a storm, or there was an earthquake and some disaster happens, the idea is to apply geospatial analysis to estimate, for example, how many people were affected, where the storm is going to land, and so on. Yep, and we use a lot of Python, we use a lot of scripts, and and the purpose of this talk today is to mention duckdb. It's a new database that is going on, and people are using it a lot. And there are some advantages that for us is a really a big win and really useful. So let's start. And the agenda for this talk is going to be divided into two big sections. The first one is to talk about a brief intro about GIS. What is GIS? What is vector data? What is raster data? And the second one, we're going to go into the code. So I'm going to show how we use finding points inside a polygon, how we intersect polygons, and so on. And we're going to use duckdb. So let's start first with the introduction. And yeah, geographic information system introduction. And what is exactly GIS? So we have a globe, we have the planet, and usually we have information inside that could be useful for us. So you can have locations of points of interest. Where is the nearest hospital from the university? Or you have the name of the university, addresses. You have information about temperature. You have information about rainfall, and so on. So basically, geospatial data is a systems, or GIS are systems that can help us to deal with data. And we can capture, we can store, we can edit, we can analyze, and also we can display all this data. For this talk, for this presentation, we're going to deal and focus on, this didn't work. Better. So we're going to focus about how to store, how to analyze, and how to display the data that we're going to use today. So the data, it might come in different ways, or you can collect information in different ways. So usually you can have paper interviews where people go, for example, you can just want to collect about how many people are living in a house, or you want to know what is the address, or some number of floors in a building. So people go into the field or go into an area and start collecting that information into papers. They just fill the forms. And then someone takes that paper and then digitize that information into a map. Also, you can use mobile phones. So instead of having the forms in paper, you can also have a digital form that people fill in the smartphone. And also you can collect straight from the GPS of the smartphone that information or the location. Airplane data or satellite data, so usually it's mostly for raster data. I'm going to explain later what's the difference between vector and raster. But usually it's transportation or some devices that are on the air or on the space that are capturing using cameras. So you can capture flooded areas. You can capture buildings destroyed after an earthquake, or you can capture vegetation information, and so on. And spatial versus non-spatial. You have points, lines, and polygons that is going to be used for vector data. You can have tables. So tables, it can give information about addresses. You can have, as I mentioned, and also pixels, as I mentioned, a satellite captures information from vegetation and so on. So how do we represent geography? And this is not working. Okay, I'm going to go straight here. So we have discrete objects. So these objects are defined boundaries. So you can have the boundaries of the countries, or you can have the lines of the roads, or you can have the polygons of the buildings, which are points, lines, and areas, and those are countable. You can count how many geometries or how many of these objects are in a given area or a given region. and they are likely persistent through time. Usually, the boundaries of the countries don't change. Those are like remain statically. They could be, unless there is some like a political conflict that implies some separation between boundaries, and then you can create another boundary, like Sudan and South Sudan, for example. Or now the conflict or the boundaries that you need to set across like Nicaragua and Colombia for the San Andres and Providencia Islands. So you can, the delimitation of the marine areas or the boundaries of the ocean, so on. Or continuous fields, which are like properties that change over space. For example, vegetation and urban areas or population information. So the number of people that can be here in like 1 kilometer area or like 100-meter areas, if you move like 100 or 1 kilometer more, you can get another data. So it's a small change, small area section that can be varied through time. So those are like considered continuous fields. And then I'm gonna show you in the main difference now with the tools. As I mentioned, those values are function of location, and then you can get a single value at any point. And can be attributes, so you can, examples could be soil moisture, like water depth, temperature, and so on. So these are like examples. So this is like the delimitation of a lake. This could be vegetation like crops, landfall crops. And these are like buildings, roads, and points of interest. So these are considered discrete objects. But for continuous field, you can get like a topographic model. So you can get like the level of altitude of a given point. Water discharge, so you have the river, and you can get the level of the river at a given point or a given location. And this is the example of surface temperature. So you can see that in some areas, some could be like hotter or warmer than other ones. And the discrete objects are considered like vector data. So these objects could be points, lines, and polygons. So these are, for example, of points, and then these are considered lines, which represent roads, and these are the polygons, which are considered the buildings. And we can just digitize them and have that information as considered geometries. So usually, when you work with vector data, you can have information associated to the data itself. For example, for the buildings, you can have the building name, the number of floors of the building, the type of the roof. These are like a tabular information. Imagine like an Excel file. But you also have the geometry. So that geometry is like the geospatial additional attribute that can give you of the information about the location. You can get how many, like if it's a square, if it's a rectangle, you can get the area and so on. So usually when you work with vector data, you have attributes and also you have a geometry. So not necessarily a geometry needs to be a polygon. You can operate with points. You can also operate with lines, and then you can combine them together. And I'm going to explain to you a little bit later. So yeah, as I mentioned, vector data is spatial data consisting of two parts. You have the geometry, you have the attributes, and they represent the shape of the phenomenon. And that information together, you can have you can combine the attributes and you can combine the geometry with the geometry, and you will get something called the geospatial feature. These are the examples. You can have a point, you have a multi-point, line string, linear ring, and combinations between different geometries. And rasters is the ones that we were talking about how to represent continuous fields. So for people that have like experience working with like digital images, they will be familiar with the term pixels. So each pixel, it gives you a value that represents something. It represents like temperature, can represent like elevation and so on. And each square denotes an area or denotes like a possible area. So for this example, you can get like vegetation difference between like urban or not urban areas, and each square has an area of like 100 meters and 100 or 1 kilometer, it depends. But it gives you information. So for the pixel's color in like green, it denotes like vegetation. But the other ones could denote like urban area, could be a building, could be something, could be a stadium. So, but these values, they are like changing across small areas, different than the vector information. The main difference, each one has its own pros and cons, and it depends on what you want to do. You need to use vector, or you need to use raster. And then I'm gonna stop here just 1 second, and then I'm gonna move to this tool. So for this, I have an example. I'm using like QGIS. I'm just gonna explain. So this one, I have like globally all the administrative boundaries of globally. And then if I want to select one, this is the admin 0. I want to get information about Colombia. So as these are considered the attributes of Colombia, and this is considered the geometry. So I can go here, but if I want to go to the admin 1, so this is like a different, like a more precise breakdown, you can see that if I select here, I can get all the departments. So these are like different types of data. These are like different layers. And each layer has its own attribute, and in this case, both they have geometries. The same geometry, sorry, that is a population. But if I select this one, so let me select here, and I'm gonna show here, this one is raster. So if I zoom higher, you can see the pixels over here, and this pixel represents the level of the count or the number of people living in that small square of 1 kilometer. So this is the value that you can, let me zoom 1 second. Oh. What happened? We lost connection. Oh, we're back. Okay. So these are like the values that you could get for the population. So this is like how, in this way, you can see the main difference between vector and raster data. This is like this is a raster layer of population of Colombia, but then you can load another raster that will represent like flooded areas, or you can just have another raster that will have other types of representation. But in general terms, a raster is like an array of pixels that gives you a given value over a given area of like 1 kilometer, so on. So, yep, and let me continue here. And usually when you don't usually operate with just one layer. When you want to work with geospatial data, you can use like a combination of layers. So the data can be like a small database that will have like a base map, the information of the base map, and then you can start adding different types of layers on top of that base map. So you can have rasters, you can have vector data, and so on. And then you can have it as small that you can share it to other agencies, and you can have other things to do with it. So now, to conclude this is I'm gonna go to, this is like a small introduction, and then we're gonna go to the code. So let me just zoom a bit here. Yeah, better. So now we're gonna go with working with like geospatial data. So now you have like a small introduction or small overview of what is the data that we work with, what is vector data, what is raster. But the idea of this like talk is like give a brief intro about how we use and how we operate with that data right now. And we're gonna use duckdb. So, and that the purpose of this talk is also to mention that the duckdb is like a database that is like pretty easy to work with, pretty easy to load data, how it's easy to store that data, how to easy is like make geospatial operations with that information. Everything's like integrated into the tool. For people that have experience working with like GIS information, you may have experienced some like issues with like when you want to combine multiple libraries, when you want to load data from a database, when you want to fetch information from somewhere, how you want to work with that data, and it's could be kind of stressful, but duckdb is quite like easy. So let's start. And for this presentation, I'm gonna use this tool. So duckdb is the one that we use. Folium is going to be the one to visualize the map in the web map. GeoPandas is to load the data. Marimo, for people that have familiar with Marimo, it's basically like a Jupyter notebook that is like more interactive. And this library is going to be used for apply something called zonal statistics that I'm going to explain later. So yeah, initially when you work with duckdb, what you need to do is first create a connection. So when you say duckdb connect, what it's going to do is to like having, it's like setting up your own database, but instead of having that database in like a different Postgres that is going to be like in a folder somewhere, it's going to be stored in memory. So your database is going to be only in memory, and then you can just, and it won't have any table, and then you will start including data from different sources. Could be a file, could be a URL, and so on, and then you can start combining with them. And here, I'm gonna install some extensions. So the spatial extension is the one that is gonna allow us to work with like with GIS, with like vector data. HTTPFS is the one that we're gonna use for working with remote data. So instead of like copying the data locally into your computer, what it's going to do is to fetch straight and then load it straight, fetch straight from the URL and then load it into the database. So when I run this, you will see that the connection is already set, and it won't have any, it doesn't have any table. So as I was mentioning, we have vector data that is like spatial data, consists of two parts. We have the geometry and we have the attributes. And then duckdb works with SQL queries. So when people that are familiar with like Postgres or PostGIS, what you need to do is to create like a SQL query where you want to do when you want to do something. So in this case, in this small example, what I want to do is I would just want to create a point. As you can see here, I have the point with this location, with these coordinates, that is like the longitude and the latitude. And then this is going to be our column, which is the geometry. And I can then, once I have the geometry, I can work with that. So in this case, this small subquery is going to create the geometry, which is a point. And then what it's going to do is to evaluate the area of that geometry, the length of the geometry, and the geometry itself. So for points, you will see that a small point, that is, yeah, a point doesn't have area, and a point doesn't have length. Okay? But if we switch, and then instead of making a point, I will want to make a line. So in this line, I will just set these 2 points, and for this case, I won't have an area. I will have a length of the line string, and this is going to be the geometry that I create. And for the case of polygon, these are the polygons where it has like a multiple lines. It's going to be a closed one. In this case, you will have an area, you will have a length, and so on. So this is like the main. This is how like duckdb interprets or understands. So usually you have like a table where you have like the attributes, if it's like the number, and so, or it could be a text or something. But also you will have another column, which is the geometry. So as shown here, this is like the types of the data, and this is the geometry that I'm going to work with. So yes, I have the geometry, and this small example here, what I'm going to use, I want to load, yes, I want to load from a CSV file. So I have this example here, which is the relative wealth index of Colombia. So relative wealth index is like, it represents the level of wealth of a given area or a given location. So this is like a set of points, and each point gives you how wealth that area is across an area of 2.4 kilometers. So I can know how wealth an area is, and if they can have like a high level of food security, or they can be like prone to poverty, or if something happens, which are going to be the points to focus on. So I have this CSV file, which you can see here, and then I'm just going to use a small query in duckdb that I want to select everything from read CSV. Okay? So this is the table, and then you will see the attributes. So you will get here the location, which is the latitude and the longitude, and the value of wealth index. So if it's negative, means that the area could be poor, while if it's positive and if it's high, it means that the wealth, that area is like really high level of wealth. And this is an area which I'm not going to focus on for this talk. But the problem, and as I mentioned at the beginning, you will see that the columns, you will have the values here, but you don't have the geometry itself. So you will need to transform that location, that latitude and longitude, you will need to transform into the geometry that we're going to work with. As you can see here, what I'm going to do is, this, yeah, as I mentioned, this is the latitude, the longitude, the wealth index, and the error, which are doubles. But now, what I'm going to do is to make it geospatial. How I do it is I just create the table again, and then I just select the items that I need, for example, the RWI, the error, but I will take the columns of the longitude and the latitude, and I will just make a point. And it's going to be our geometry. So when I run it, you will see here that the tables or the column names changes, sorry, the column types change, and now I have the geometry. And once I have this, I can start like operating and I can start making combination with the data that I have. So, okay, I'm gonna just go back, let's go forward, and this is another example, and this is like how to load remote data from a URL. So I have here the values of the municipalities of Colombia. This is a file which is a JSON file, and I'm gonna load it remotely. What I'm going to do is to create a table, and I'm gonna select all the parameters, and from this one, I'm gonna take the administrative names, and the admin 2 and admin 1. And for this one, I'm gonna take all the geometry, all the admin zeros or globally, which is this layer. Let me hide it here for this layer. So we have the data, but instead of copying the data from locally into the computer and then load it into the database, I'll just set the URL and then straight it goes straight to the database. And if I want to describe, I will just get these boundaries, which are these ones. But if I want to go to admin 2, you will see that I will get all the attributes that I mentioned regarding the municipalities of Colombia, and I will also get the geometry that I want. So now that I have the geometries, I can start doing operations with those geometries. For example, this is the layers that I will show you now. These are like the points that represent the wealth index of a given location. And these are like the administrative boundaries. So if I want to get all the values for Colombia, or for my city, Barranquilla, I will just select the admin 2 dropdown, which is here. I will select the boundary, and then what I want to do is to find which are the points that are inside the boundary of Barranquilla. So here you can see these are like the boundary of my city, Barranquilla, and then you will see all the points that are within that polygon. And then I can just, one second here, which is better. I can just apply field, change it if I want. So if I want to get to Medellin, you will see that I can change and I can just filter the points that I want. And if I want to get to Bogota, for example, I'll select and you will find it here. So the query, or what it does is I just make a filter that I just want to get the geometry for the city that I want, Barranquilla or Medellin and so on. And then I will just want to find which are the points that are within that polygon. So, and everything is done inside duckdb as a query. And then we're gonna jump this one, and then I'm gonna go here, and then what I'm going to do is to create some squares. And this is like a small combination because, as I mentioned, the relative wealth index gives you information of 2.4 kilometers. I just want to create a square. And finally, I'm gonna filter for a city, and I'm gonna apply something called zonal statistics, which is, I take these boundaries from what I want, and then I take this raster, which is population and so on. The zonal statistic, what it does is that it takes the intersection between the raster, and then you can just compute a value. So in this case, it's going to be like maximum, minimum standard deviation across those pixels of that raster. Because what I want to know is that for these squares that I created, using duckdb, I will combine those squares with the population information, and finally want to know how many people are living in that area, those areas. So for this case, I want to select four. Okay, I want to select four in this, the department of Caldas, and I want to get how many people are living that they have like a low wealth. But if I want to switch for this one, I can get all the information of the population that are affected. They have like a low wealth. So it's like a combination of different tables, and then you start like, okay, I have these attributes. You start like applying joins. You can apply zonal statistics and so on, and then you can get that table generated. What is the advantage of duckdb is that everything is inside the tool. So you don't need to manipulate, you don't need to load different tables, different libraries to work with it. You just have to use duckdb and start making queries to get that. So yes, I have 5 minutes. Okay, just want to show something, which is why we have all of this. So in WFP, what we do is that we can have information about the polygons of like a storm. So this is an example of storm forecast. It gives you like information about where the storm is going. And once we receive that information, we start like checking if the storm makes landfall inside the boundaries of the country. So this is an example for Mozambique. And once it arrives and makes a landfall, we can start applying more analysis. So now we know that there was an intersection with the country and the polygon of the storm. And once we do, we just apply more analysis to know how or which are the districts that are going to be affected by that. So we have 3 polygons right now. We have the polygons of the storm, we have the boundaries of the country, and we have the cities or the districts affected by that. So we can run estimation, we can run combinations, everything inside duckdb queries, and everything is stored, and then we can just analyze and then load and show that information. So this is an example of how we use duckdb in terms of emergencies, but you can extrapolate to other times. So you can, to extrapolate to other hazards. So earthquake, you can extrapolate to floods, you can extrapolate to any hazard that you want to work with. But everything's like a combination of different geometries. So I think I was quick, but thank you.